Hey everyone, my name is Akil Doka. Welcome to this amazing panel session. We're going to talk about physical AI, and I hope that all of you are having a great CES. This is my first time here, so super excited to be here. We talked a lot about AI at CES. You saw Jensen's keynote. He really talked a lot about physical AI and robotics, and we're going to continue that conversation in the panel discussion today. Much like generative AI, where today I can feed it an image or a text prompt and get a video or help me write an email or summarize a document, physical AI is going to go through the same transformation, if not already. And so today we're going to talk about the big bang of physical AI and what that really means to us. In this session, we're going to touch on a few different topics. We're going to talk about simulation. We're going to talk about synthetic data generation, what that really means to us. We're going to talk about end-to-end world models and really how they shape the development of next generation of AI robots and also autonomous vehicles. And so to sort of unpack that, unravel that for us and really make sense of it, I'm really excited to bring on our three panelists today. We're going to start with Amit Goel, who's the head of our robotics ecosystem at NVIDIA. Then we're going to have Amit. Then next is Christian Schuss, who's the head of robotics at Accenture. And then we have Raquel Urtasun, and she's the founder and CEO of Wabi. Please join me in welcoming them to the stage. So I've got my questions on my iPad, so we're gonna kick this off. I think I wanna ask for everybody to set the stage for the audience, because everybody's familiar with AI, but we want to kind of dive deep into physical AI and what that really means from an industry perspective. So Amit and Christian and Raquel, we're going to kind of set the stage with a general question. So why is now the inflection point for physical AI? And what sort of market signals are you seeing that suggest that physical AI is actually moving from, let's say, the labs where it's more like a skunk works project to actual implementation? So Amit, help us understand that from NVIDIA's perspective, and then Christian and then Raquel, we can sort of continue that conversation.
Thanks, Akhil. We are seeing a big inflection point on AI going from digital world to the physical world, and it's coming from a combination of few things. The first is on the technology side, of course, with the advancements that have happened in generative AI, in simulation, in large language models. We have now come to a point where we can have models that can understand the physical world. And physical world is far more complex than the world of words. So we have the technology and the infrastructure now to actually make sense of what's happening in the physical world. So that gives us an opportunity to bring AI to the physical world and make robots happen. The second big reason is just on what's happening on the industry side of things. As we are seeing advancements in digital AI, all the rest of the industries have made a lot of improvement. But if you go to a hospital, if you go to a store, if you go to the streets, if you go to a manufacturing plant, they haven't really reaped the benefits of AI. And we are seeing a lot of onshoring happening, a lot of more manufacturing, a lot of new industries emerging. The demand from the customers is changing. So how we manufacture things, that has evolved quite a bit. And the only way to be competitive and sustainable manufacturing is through automation and AI. So we see a lot more need for physical AI and robotics to be introduced into manufacturing, to be introduced into the physical world in order to be competitive, in order to be safe, in order to make efficient products. So a combination of the AI technology, the simulation technology that allows you to create physical AI, combined with the need from the industry to really accelerate and automate processes, that's what's driving the big wave of physical AI and robotics that we are seeing now.
Thanks so much. Christian, I don't know if
Okay.
Can you all hear me okay?
So I can just echo what Amit shared. I think that we clearly see that the technology is ready today at multiple dimensions. Firstly, we have these massive investments happening in the industry of accelerating the investments on VLAs models, VLMs models, and accelerating the production of data to train those physical AI models. So today we have, in terms of technology, clearly a huge potential for accelerating physical AI. But the dimension of the digital AI technologies reside in hardware. And we see as well massive investments for accelerating those new hardwares. So when we speak about robotics and physical AI, we're not speaking about the traditional robots, but also those new form of robot that is bringing more sensors, more cognitive capabilities, and the ability to integrate with physical AI solutions. So this is truly an amazing time where humanoid, drones, leg robots, and many other form factors, autonomous vehicles, are going to adopt those physical AI. From a client standpoint, we see a massive expectation for bringing the next level of autonomy. So not just automation, but how we are bringing systems to be more autonomous and having a live and understanding about the situation to adapt and operate. Of course, it will be driving some key question about how it's going to be released at scale, but I think that we'll have some time to discuss about those points later on. And the last point is, of course, is a massive investment across the industries to be accelerating this transformation. Everyone perceives physical AI knows an incremental transformation, but that is a real reinvention at the core of the business. So that is an exciting time for us.
Yes, so I will add my maybe 2 cents to this. So I'm going to reiterate some of the things that you guys already touched upon. But I will start by saying that, physical AI is here. The revolution is starting now, but it's going to transform everything, the world as we know it. And I think that, it's going to catch a little bit by surprise the real world in terms of people don't necessarily expect robots to be, within us. In the 5, 10, 15 years time frame everywhere. But that's going to be the case. Now, if you look at why now, right, which was your question, I would say that for me is really the combination of 3 things. We talk about the technology, and one of the things that is important with physical AI is that there is a lot more requirements on the technology compared to the digital world that I don't think is necessarily talked about enough. Because these are physical machines that are interacting typically with humans where safety is a must. And proving safety is the first thing that you need to do before deployment, for example. So that's, you need to develop many things to have real-time systems that can safely operate and live with us in the real world. So I would say that's one piece where now technology is ready. The second one you touch upon is hardware. If you want to bring this safe technology, it's not about a prototype robot, etc. You need to really be able to qualify hardware and be able to validate and verify it so that it's always going to do the right thing, right? So there is a lot of investment in I do self-driving. So in the self-driving domain, in terms of OEMs that have spent billions of dollars, the 5 to the last 10 years. Spending into this next generation of hardware ready for self-driving. So that's now. So that's coming also at the right time. And the last bit is about, well, all this technology is great, but if people don't want to use it, it doesn't matter, right? But when you look at, we do self-driving trucks in the trucking industry. A few years ago, when you went and talked to the big shippers or the fleets, it was always like, I don't know, maybe yes, maybe not. Today, every single person will tell you is, I want this technology now, how many can you give me and where can you operate? So it's very clear that, the world as we know it is not sustainable, driver shortage for us is real, and this technology is really providing a solution that is solving real world problems, and therefore the customers are there ready to really, utilize it, big time in the real world. So it's these really 3 things that you need in order to see, the big revolution coming today.
Awesome. Thank you so much. This was great. Sorry. I want to switch on 2 things, technology and hardware. But let's stick to technology. Jensen talked a lot about, in his keynote, pertaining to simulation. We saw a lot of the discussion around that. He always talks about simulation first. And this question is more for Christian and follow to Raquel. Christian, let's start with simulation. You work with a lot of clients, and how are you what sort of insights are you getting from them from a simulation perspective, and how do you sort of talk to them about that?
So simulation, broadly speaking, you have multiple levels of simulation, and I think that we shouldn't get to confuse everyone about what we mean by simulation. That is very broad. There are simulation intending to be designing a process and optimizing a process that is typically thing that we can do from AGs already, but that has optimized by using the latest technology of Omniverse to get a more photorealistic, more realistic rendering of how the process is going to be executed. The second level of simulation is where you start to bring the physics simulation and where you can replicate the physical behaviors of your environments and of the robot and autonomous systems behaviors, where you can duplicate the brain of a robot in a simulation engine. So when we have a humanoid simulated in Omniverse, for instance, we can just bring the virtual version of a humanoid, but beyond the visualization of the humanoid, you have the brain of the humanoid. So you can discover the space and behave exactly the same way it would have behaved physically. And simulation comes to be a place where you can test out your processes, test out your activities, trying out which kind of form factors you need and how you can optimize the intelligence of your robot. But more importantly, producing the data, because physical AI is primarily relying on data, and we don't have those data available. LLM rely on a lot of available data from the web. We don't have those data. So physical AI is frequently connected with simulation because without the data, you can't have physical AI models.
No, that's a great insight. And I want to continue, Raquel, with you because, to train, like Christian said, to train these models, you need a lot of data. In your experience, how, help the audience understand what synthetic data really means. And then if you could lead into a little bit more about how you use synthetic data today at Wabi to sort of build the next autonomous systems that you're looking at today. Yeah.
Yeah, and I will say that at Wabi we use simulation for everything. We are a simulation-first company. So it turns out that when I started the company, 4.5 years ago, the first thing that we built is not the robot, it's not the autonomy system, was the simulator. And this was, at the time very contrarian. This is, we built a neural simulator at the time where, now it's mainstream, but definitely many people, were very confused about what is this, what are you talking about? But what is very clear is that, there is many things that you can do with a simulator. One is, creating synthetic data for training the system. And in self-driving, this is tremendously important because you need to make sure that the self-driving vehicle is going to do the right thing in the event of a safety-critical situation, an unavoidable accident, for example. You're going to minimize the chance of injuring somebody, for example, right? And it's not that you can just go in the real world and test it, right? So you don't have a choice, right? Simulation is the only thing that you can do where there is no consequences. So I will say, for training the system, but also for proving the safety of the self-driving vehicle. If you look at the number of miles that you need to drive today in the real world in order to even see one fatality, say in highways, is 100 million miles. And if you want to have a statistically significant evidence that your system is safer than what humans do today, right, you need to do that many, many times, right? So real world is just not an answer, right? So that's where, simulation and synthetic data are tremendously important. But when you use simulation, particularly for safety, it's very important that you're also able to prove that the simulator is realistic. When you use it for training, it's less important, right? So long as it it helps the system learn, it's fine. But for safety, you want to use it for proving your safety case, then it's a must, right? Because you need to be able to show that when you're saying that your system is able to work better than a human, that every single one of your tests is reflective of the real world. So I would say that has put a lot of kind of emphasis into bringing simulation systems to the next level. And that's something that Wabi is at the forefront of the industry in terms of really pushing the needle of being accountable in terms of what the industry should be doing in order to showcase that whatever we utilize is safe and we can prove that indeed is safe. And the last bit I will say is that we actually have a form of simulation that nobody else utilizes that is really exciting, which is we actually use augmented reality by bringing simulation to the physical world. What do I mean by this is that in order to test the safety of self-driving systems while driving in a closed course, in a controlled environment, we actually bring simulation to be able to take the real world sensor data in real time and corrupt it so that the self-driving vehicle thinks that there's all these complexities and situations and accidents and whatnot, and we can actually see in real time as it's driving that it will be able to do the right thing. And there is no other technology that can actually do this. So simulation is more than just offline sim. You can actually bring it to the physical world, and it's amazing what this can really do in order to really bring physical AI to the next level.
Yeah, and adding to what Raquel just said, I think simulation is essential. I don't think it's possible to have physical AI without simulation, because of the fact that any AI, let's assume you manage to get some data and train, you have to evaluate it. Every LLM, every model that gets trained has to be evaluated. And you cannot evaluate these things in the physical world and say, a thumbs up or thumbs down. You got to simulate it in order to know whether the model that you've trained, because there's a constant data flywheel that you're getting. New scenarios, new data comes in. You're always training the models, and you absolutely need to test them before you deploy. And the only way you can safely and efficiently do that is in simulation. So that's been a big part of how physical AI is making progress.
That's super cool. So I think maybe the soundbite is safety is born in simulation. So I think we all agree with that. I want to switch to, we talked about simulation and data, and Jensen announced Alpamayo at his keynote. And Amit and Raquel, I'd like your insights a little bit on what it means to talk about end-to-end models. How does the audience today sort of get their heads around what does it really mean? Because from an AI perspective, it's always been an ensemble. One model does one thing, the other one does something else, and then you sort of stitch it all together. So Amit, starting with you, give us an insight on what it means from a robotics standpoint, and Raquel from an autonomous vehicle standpoint. So Amit, please.
Sure. So we started working for robotics and AI 10 years ago. And AI has been in robotics for a while, but it has been evolving from various forms of perception, just understanding what the robot sees. But the rest of the stack, which includes once I observe something, what is going to be my plan of action? Once you decided the plan of action, how am I going to act and actually do that plan? These are three main components of a robotic system. Even though AI was helping on the perception side, the planning and action were still human-written code. And if you think about the possibilities of planning and action, they are exponential. As the degrees of freedom increase, as the number of joints increase, the possibilities that in which you can move your body, you can accomplish a certain action it's very, very hard. So it's a continuous spectrum. It's so humanly impossible to actually explore that entire space. So a lot of heuristics were involved. And that is what made robotics very fragile. Even though the robots could understand, they could detect things, they could see what's going on, segment the world, but planning and action was still human-written code. So you could go after solving one problem at a time, but it made the entire development process very slow and the resulting products very fragile. What end-to-end learning enables is it goes from observation to action. So because there's information that perception has gathered that is useful for planning, there's information from planning that's useful for action. By combining it all together and making it learn end to end, it's now truly possible to create generalized models. And what generalized models means is if I learned a skill, if I'm a robot, I learned how to pick up a certain object and place in certain places, and the next thing I have to do is actually clean my desk. There are skills that I learned during picking and placing that are actually useful for cleaning the desk. In the old paradigm, when you had separate models for perception, planning, and control, there was no leverage. Every new skill required new amount of data, a lot of development. But now, since it's an end-to-end model, as you keep adding the data to it, the model generalizes, it learns from what it has seen before, and the next new learning is much easier. So now we have that ability to tap into the large-scale data, get into a data flywheel, train a model that is multimodal, that can do multiple tasks, and that allows the technology to scale. Purpose-built robots have been there for forever, but if you go to a factory or if you go to a warehouse, or if you go to a hospital today, most of the times where automation is not there is because the robot is not just that person or that task. There's not one task that you need to do all the time. You're doing a little bit of task here, a little bit of that. So now with generalized models, end-to-end autonomy, you can get into a data flywheel, build robots that can be scaled for multiple tasks.
So atoms to actions, basically, right?
That's right.
Raquel, please, your insights on this one.
Yeah, so I think it's interesting to kind of see this, your question, from the perspective of also the evolution of self-driving. And if you look at, since the DARPA challenge, right, the majority of the time has been dominated by what I say the classical roboticist mindset, which is this idea that self-driving is a very complex task, right? From you have your sensor data, right, and you need to come up with the right action, and the approach is really divide and conquer, which is let me split the task in terms of a gazillion, I will say, of subtasks, because we oftentimes in the past we talk about perception, prediction, motion planning, and people think it's 3 tasks, but no, this is not how those classical stacks look like. There is hundreds of models inside what I call the spaghetti stack, right, where nobody within the company understands what actually the system is really doing. But from a perspective of you can divide the problem into sub-problems. You can try to solve those with the hope that you can piecemeal together all that in terms of a system, and then somehow you're gonna hand engineer and put all the knowledge that you have as a human in terms of that that system. So what we saw is the evolution of that a little bit in terms of with deep learning 2012, I guess, and the big moment in computer vision of the revolution of yes, hacking features was not gonna continue working. We saw that what these roboticists started doing is let's bring AI people to take every one of these models and maybe put a little bit of AI, and then that actually help and bring that to a better level of performance. Now, what we've seen, right, if you take an AI mindset, not a roboticist mindset, you actually have the opposite philosophy, right, which is, I dedicated the last 26 years to do AI, and then what you always think about is, I want one model to solve the task, right, and we have data, and I will have training, testing, and you do this with generalization is the first thing that you come to mind. Versus this specificity, canonical routes, and so you really come from the polar opposite perspective compared to the traditional roboticists. Now, I think it's important also to know that then everybody has in mind that end-to-end means that it's a black box, kind of like a big neural net architecture. Well, that's not necessarily the case. It turns out that you can do end-to-end, right, which is this thing that you can actually train the entire system in a single go, but you have the choice of what the architecture is. And then is when it becomes very, very interesting, where you can take some of the learnings and things of the last 20 years and then bring into modern AI. And then you end up with models where you can actually build interpretability inside. You can build reasoning inside as well, in a way that you get the best of both worlds. You get the full power of AI, and you get the ability to really validate and verify that the AI system is going to do the right thing. So that's what we are doing at Wabi. Where basically think of it as full end-to-end, but where you really are able to prove that the system is actually safe. And I think that's what we're going to see more and more is forget about black box, the fact that proving that the system is doing the right thing, the fact that you need to, for us, if a self-driving vehicle gets in trouble, that's the wrong thing. The first thing that needs the regulator is going to ask you is why. So you need to explain this, and you cannot just say, well, this neuron fire, and then therefore decide to do this. So you need to build very different systems that are able to really explain and interpret and be able to verify.
That's amazing. Thank you for that. Christian, I want to switch to you and very quickly help us understand how, especially if, in the audience, they're probably thinking, how do I bring physical AI into my own enterprise? And so you work with a lot of enterprises. Help us walk through kind of like 2 or 3 high-level points that you want to share today as to how they should go from proof of concept to implementation.
So it is, of course, a critical question. POC was more 2025. I think that today we are not anymore in the POC. We are really looking about scaling. And most of our clients are in the stage of accelerating physical AI drastically in 2026. So we need to have a strategy in place. This is pretty obvious, but I think that for physical AI, everyone that is working in technology, running a company, look about physical AI, not just adopting physical AI, but be part of this economy. It is a trillion economy. And your companies could be, of course, adopting physical AI, adopting robots to be deployed in manufacturing and warehousing. But you own data. You have infrastructure. You can be part of this economy. So physical AI today is a huge and massive revolution across industries and across businesses. So you can be part and you should be part of this physical AI revolution. So when you are running your strategy, beyond looking about the use cases that you can start to automate and bringing robotics, look about what is your economy, how you will be part of this economy, how do you take advantage of your data, infrastructures, people to be driving the future of physical AI revolution. So this is strategy-led. Define your ecosystem partners. Today, there is not one single company that will be driving the revolution of physical AI. NVIDIA is certainly an important and a critical partners, but it is all about building an ecosystem, because even NVIDIA is powering the processing computation capabilities, bringing the simulation. You need platform for orchestrating the operation. Everyone is looking about individual robot for starting a POC. You will have thousands, millions of robots running in your sites, and you need to have ways to have a platform to orchestrate those operations. So really, truly driving a strategy from your business, from transformation, driving your ecosystem developments, and of course, looking about how you are going to define a very aggressive roadmap, because today it is a time to accelerate, not a time to run POCs.
Amit, do you have anything to add?
Yeah, I would just add to Christian one thing that he mentioned about the need for ecosystem, and that's core to everything we do at NVIDIA. That's the reason Alpamayo, entire data set, the model is open, Groot, Cosmos, everything we built, all these models are made open along with the data, because as Christian said, the physical world is so diverse. Everybody's applications are different. Everybody's data sets are different. So we really truly believe in the need for open source and open models for physical AI, so that every industry, every application, every developer can take those, bring their own data, bring their own domain expertise, and use those models to create physical AI solutions.
That's super cool insight. So next question for all 3 of you, more like a speed dating thing. So Amit and Christian and Raquel, 2026 trends. What are your bold predictions? So Amit, take us away.
For me, I think it's one of the big challenges for physical AI has been data, and I truly believe in 2026 with the power of world foundation models like Cosmos, and as Jensen said yesterday, we're going to make compute a solution for data. And as we know, compute is scaling pretty fast. We're going to have exponential compute available. So I'm hoping that in 2026, the physical AI industry will find a solution to the data problem, and once that is solved, then we're going to see a lot more physical AI applications.
For 2026, I will be looking for the ecosystem development. You can see the largest announcement that happened at the CES and recently was the announcement of partnership between giants. Accenture, NVIDIA last year, we had a lot of announcement with the Siemens, NVIDIA. So there is a lot of announcement of alliances, because no one can really transform the ecosystem and running this revolution alone. So this is an important things to focus on and to observe and to understand. And again, individually as CEOs and leaders, how you are part of this ecosystem. That is a critical thing that I will be observing for this new year.
Yeah, and I would say that for me, it's really about thinking about what is the first application where physical AI is really going to be widespread, and this is self-driving. And this year is the year where you're going to see widespread tracking. So really, really exciting.
Super awesome. Thank you all. And thank you all for attending. And in true Vegas style, may your vibe take you where you want to go. Love to congratulate all our panelists today. Please give them a big hand. Really good insights. And have a great CES. Thank you.
Thank you.